So let's repeat the question. So the question is, wouldn't it be simple, just like we did with initial with shot count, to make the maximum shot count a global variable, right? Remove it from here, make it a global variable, and then we don't have to declare it here. It's already there. And we wouldn't even have to make this part of our function call anymore, right? Because all we did was that we created another global variable. And therefore, of course, I need to update my function declarations so that they no longer expect any parameters. We say we'll use global variable. This is quite a possibility, and it's possible, and it should work without any changes from this point on. But you're absolutely right. We could make it a global variable. Now, just a reminder that global variables are those that declared outside of the scope of any function. Okay, so yes, it's possible, right? So if I build this, it should. Oh yeah, I still have to remove shot count from making my calls because my functions no longer expect any input parameters, right? So they're going back to be parameterless, right? So when I make my function calls, I need to get this out because this is now a global variable. I no longer need, according to my function declarations, I no longer need this. So let me do this again, build. Okay, so this time, if I run this, let me try 8 again, same number, right? So if I just check visually what has happened, so I still get the same result. So the answer is yes, it's possible. But global variables, although they are the fastest. Remember, with global variables, none of the copying of values has to happen. Copying values from one stack frame to another stack frame to another stack frame, of course, takes time. Yes, you're kind of wasting a little bit of your time, but this time is absolutely negligible, oftentimes, compared to drawbacks that global variables bring with them. So typically, we will not use global variables, and we will discourage from using global variables because there are alternative ways to doing this, but we will be able to cover and explain what good alternatives exist for global variables when we really begin to step into the territory of object-oriented concepts. Most likely we're going to have an object which represents this entire application, and it will encapsulate inside, keep inside the values of the shot count, which is the actual count, and the maximum shot count, which is the threshold value, which we use to control when to stop. Okay? So for now, I'll say global variables is pretty viable solution. We can discuss them. And of course, the global variables, as opposed to using the stack, they pretty much live in a separate memory segment, right? So we have this image of our program. This is our stack, right? This is heap. We're not using heap today, so heap will grow this way. It's dynamic memory. Stack grows this way from high to low memory addresses. The stack will grow, and there is a section where the global memory segment, and right now we place both of these variables right here, and our executable code, which is here in our text memory segment, all of it has direct access to these global variables, so we don't have to pass them as parameters when we make function calls. But with every function call, the stack frame, stack frames are still created for every function call, because function needs some temporary storage to at least store the return address. so that it knows where to return. When you say return, it knows who called it at which address. So stack frames are still needed for every function call, but when you're using globals, of course, you're not passing copies of parameters. So very important thing to repeat again, that when we use function parameters, regardless whether we name them the same thing or not, or when we add local variables to our functions, we need to realize that the local variables exist only for the duration of the function call. Their time span is limited to a duration of the function call. Their visibility is limited, and even if I name this, integer x, right, and this too will say integer x, these two integers, integer x, which I am giving to pong as input and ping as input, they're always completely different variables. But I do like to recycle names of my variables, because in my mind, perhaps both of them represent the same concept, the same count, the same maximum value. So if I do this, I wouldn't be shy to name my variables, give my variables the same names, the same identifiers. So I know it's kind of like, there are lots of components that we're discussing here, but hopefully you realize that I routinely refer to these little drawings or diagrams that I'm trying to use, because I like to imagine exactly how my program looks like in memory when I execute. When I look at every statement in this program, I'd like to know exactly where these variables are, how they interact, are they visible, what I can do with them, right? It's very important. So I'm trying to open up your mind in terms of this is not the only view of the program. Of course, there's lots of syntax involved. There are rules like, okay, remember to create your function declarations at the top, right? Remember to use proper syntax for function definitions, function calls, use proper parameters. The list just goes on and on and on and on. Everything that's involved with syntax. But that's not the only view in the source editor. The other view is something like that. Where are my variables? Like we just discovered here that a global variable can be an alternative to passing a function parameter. But I can assure you that in small programs like that, your compiler, which comes with optimizer, can optimize it extremely well and even return function calls in release build. And so, generally speaking, my advice to you would be, do not optimize often. If you find that you would like to use function parameters in your code, and these function parameters are convenient to you to use, don't just overwhelm yourself, but is this efficient or not? This is normal. You should be using function parameters, and I can show you a realistic program perhaps and show you that most of function calls do involve plenty of parameters. So don't be shy to use functions with parameters. So that pretty much covers up our conversation about functions. Yes, we already talked about function parameters. I would like to close this presentation and talk a little bit about some other things that we need to talk about today.